what you think. Markel, Blake, tell me what you think is going to happen. What do you think will happen if the blue cold water mixed with the red hot water? And we also still have a few of our scholars who have those cameras off. Easy way to earn a 5 PBIS points, or easy way to not get that 5 is to make sure that camera's off. So please turn it on for me, please, if you haven't. Thank you so much to my scholars who already have. Okay, so I'm getting some good guesses in the chat. Some people are saying it'll mix warm water. Some people are saying it'll mix. Some people are saying it won't mix. Well, enough of the predictions. Let's actually take a look at what happens, all right? So here's what I want you guys to do. As you watch the video, jot down the observations, not in your notebook, but in class kick, okay? So in class kick, you do have a slide that'll be up, and I want you to tell me what is happening to the water.
A card and a dish. Make sure that one of your parents is around to give you a hand with this experiment. The first step is to pour the red food dye into the hot water jar, and then very carefully stir it around to mix the colour.
Mix. Molly says the red's going to go down, the cold is going to, or the red's going to go up, the cold water is going to go down. The blue will mix into the red. Okay. All right. Not going to mix because they're different volumes. Okay, Kennedy using vocab words. They're not going to mix. All right. So, all right, let's take a look and see what happens when you slide that card away.
As they do, you'll see that the water starts to mix, which forms a pinkish purple colour. As each of the jars mixes in with the other one, you'll see that the colour evens out completely. This is because the water is very slowly mixing all of its molecules together. Now try this. Take the jar of red hot water, place the card on top, and repeat the same steps. This time the blue jar is on the bottom, and the red jar is on the top.
So now, he flipped it. He did it upside down. So we saw that the first time he did it, the cold water was able to mix with the hot water when we had the cold water on top and we had the hot water on the bottom. What do you think will happen if we flip it? Do you think it's going to be the same reaction? Sean said it's not going to mix. Elias is not going to mix. No? Why not? I mean, it's the same thing. It's just cold water, hot water. All you doing is flip it upside down. The water's still going to mix, right? Right, Zamari. So Zamari said, yeah, she thinks it's still going to mix. I don't see why not.
No.
Molly said one has higher density. How do you know one has higher density? Okay. Because it's different mass. Okay, so I'm seeing a lot of vocab terms. I'm saying there's different densities, different masses. Let's actually take a look and see what happens this time when the cold water is on the bottom and the hot water is on the top.
Have someone very carefully remove the card from the middle. And this time you'll see that the jars don't mix. So why is this? Is it the colours? No, it's not. In fact, the hot water has a different density to the cold water. It's very slightly less dense than the cold water, and so sits on top. When we compare them side to side, you'll see that the reaction is completely different. This is because the cold water in the first experiment is more dense than the hot water, and so sinks straight through all the gaps between the molecules in the hot water. And there we have it, a really...
So bang, just like most a lot of us said in the chat, the two have different densities, okay? So we're actually going to take a further look.
And a dish.
So we're actually going to take a further look at that, right? So yeah, Tim, that was pretty cool. And actually, that's one of the things that I really wish you were in school for, because actually, last year when we did this experiment, this was my first experiment that I ever did with a class. So this would have been really cool to be able to do it again with you guys, because technically this is the 1-year anniversary of my science experiment. So thank you guys for being the first group to be there with me. But I will say that we're going to take a look at what the difference between the two were, right? So we saw that when the hot water was on the top, that it was able to sit on top. When it was on the bottom, it was able to mix, right? So that means that the two waters had different densities, okay? So, which color was the most dense and why? Who can tell me which one was the most dense and why? Okay, I'm seeing a lot of people in the chat. Deshaun, would you like to share? Go ahead, Deshaun. Which one was the most dense and why?
The most dense was cold.
Okay, how you know?
Because when he had put it on the top, it sunk right through.
Mm-hmm. And then when it was on the bottom, what happened then?
It didn't mix.
Exactly. So similar to when we did things that had higher density, which was heavier, the solutions that had more sodium in them, those are the ones that either went straight through or they stayed at the bottom, right? So the same thing, same reaction happened, but it was when the water was cold versus the water being hot, okay? So if that's the case, if the blue one was the most dense, which one was the least dense? This should be an easy question. Everybody should be in the chat with this. This is very easy. Easy. If blue was the most dense, which one was the least dense? Thank you, Zamari. The red one was the least dense, right? Because that one was the one that was able to sit on top when you put it on top, right? And also, the heavier and more dense blue went straight through it when it was on top of it as well, okay? So, what do you think the relationship is between temperature and density? Right? So, what do you think the relationship is between temperature and density? So we actually just answered this question, right? So we just said that we know that because cold air is more dense or cold water is more dense and hot water is least dense, what can you say about the relationship between temperature and density? Let's see. Zamari, what can you say about the relationship? What do you think the relationship is between temperature and density? Okay. How about Blake? What's the relationship between temperature and density? I said, can you tell me what is the relationship between temperature and density? Right. So we've already saw that the color that was the most dense was the blue, and the color that was the least dense was the red. So what would you say the relationship between temperature and density is?
The relationship between density and temperature is I don't know.
Okay. So I want you to think about it like this, right? So we remember before last class when we were looking at the relationship between layering and density, right? We saw that the things that were heavier, those are the things that went to the bottom, right? And the things that were lighter were the ones that were able to stack on top. So if we just from the video we just watched, we saw that the hot water was that stacked on top or was that on the bottom? Exactly, Marley, it was stacked on top, right? So we can say that the relationship between temperature and density is that higher temperatures equals less density. Cooler temperatures equal higher density. Okay? So that is our relationship between the two. So higher temperatures equals less density. Lower or cooler temperatures equals higher density. All right? So, like we said, Markel, can you read that first line for me, please?